Welcome you all to the Multisim Simulator environment. Today we are going to see a transformer circuit practical activity to understand the turns ratio and its relation to voltage and current in the primary and secondary coil of the transformer. We will also see the effect of load on the transformer. We are using here the Online Multsim Simulator from National Instruments. Stay tuned and follow the instructions to learn the simulation software faster. Let's begin. This is the opening window which you will see once you have opened the Online Multsim Simulator. So first let us rename it. So rename the file before we start making the schematic circuit. So to rename it, either you can rename it directly over from here, or you can come over here, open information pane, click on that, and then you can give your name here. Let us name it as transformer and its turns ratio. Right. So in the description, let us give it as this circuit deals with transformer, its turns ratio and its relation with voltage and current. That is the name and the description. Let us take it out. Right, our page is ready now. Let us start by inserting a transformer into the workspace. To insert the transformer you will be able to find in the passive components. So you can see over here on the left hand side there are many components over here. It is a set of components. It is not just one single component, it's a set of components. You will be able to find the transformer in this passive component list. Let us click on the passive, and when I click on the passive you will be able to see there is a resistor, capacitor, inductor, potentiometer, fuse, transformers, coupled inductor resistors, like that. So here we need transformers. Let us click on transformers now. Yes, once I have clicked on the transformer, you will see again there are different types of transformers. So what does this mean? So first one is 1P1S. 1P1S stands for one primary and one secondary coil. So only one primary coil will be there and one secondary coil. This is what actually we need. There are also other types of transformer like one primary, one secondary with sender tap. So on the secondary side there will be 3 terminals compared to the 2 terminals in 1P1S, and also the third one is 1P2S, which means one primary and 2 secondary. So that is not very important for us at this particular moment. Let us click on 1P1S. Left click and place it in the workspace. There you are. Now we have connected a transformer. Now let us give supply voltage for it. Normally transformer works only with AC voltage, so you have got to give a supply of AC. So where do I find the AC source? So here it is, source. You can see over here all the DC source or AC source you will be able to find at this particular place. Click on the source, and when you click on the source you can see that there are different types of source. Most of it are not very important for us. AC voltage, DC voltage are important things. Now here for us, for this transformer we need AC voltage. Let us click on the AC voltage. Left click, and now the component gets selected by itself, and then place it on the screen. Yes, left click again, so it is placed. Right, now let us make the connections, the primary connection. How do I make the primary connection? Take your cursor near to the terminals over here. You can see that the wire spool comes in picture. Now click on left click, click at the place how you want. Accordingly you can see that once it has reached a particular point, it highlights it. You can again left click that, so that the wiring is complete at that particular place. The second line, so let us again find out a terminal. Yes, there it is. Wire spool comes into picture again, and now I will be connecting into the other point. Yes, there you are. I'll be again left clicking it so that I can release that. Yes, the primary side is ready. So let us now connect to the secondary side. For the secondary side we actually need a load resistor. So where do I find a load resistor? Again I go to this passive, click on this passive, and you will be able to see a resistor R. Okay, so let me again left click that, and now by automatically it gets selected. You don't need to do anything for placing it. You have got to again left click that. You can also rotate this, like this is a rotate button over here. Click on the rotate button and you can see that it automatically gets rotated, and you can place it at the right place. Now you have got to connect this again through wire spool. Get the wire spool and then connect it in the similar way, so that it looks very much structured. Right, so that is one terminal to the load resistor. Let me connect to the second terminal of the load resistor. There you are. That terminals are also connected. Now before running it we also need an earth terminal. So where do I find an earth terminal? Here in the schematic connector you have got to earth both the primary primary and secondary. So one earth terminal I'll put over here, and another terminal I will take it and put it over here. Right. So let me again connect those things through the wire spool. There you are. Now the primary is connected to the ground terminal, and now secondary is also connected to the ground terminal. Now here you can see that the supply voltage, even though it is AC voltage, you can see the symbol of the sine wave. You can see what is that voltage and the frequency. It is 1 volt and 1 kilohertz. Let us put the normal value of a voltage and frequency. For that, let us click on this, double click. When you double click that, on the right hand side you can see that the voltage, frequency and many other parameters are shown. For us, for an AC voltage, basically we are bothered about only the voltage and the frequency. Let us change the voltage to normal voltage, which AC supply voltage which comes to the terminal at our home. It is 230 to 240 volt. Let me term it as 240 volt. And the frequency which we get is 50 hertz. So that is 50 hertz frequency. Yes. So we have identified that 240 volt and 50 hertz. That is the supply voltage and frequency. Now coming to the transformer. Let me click on the transformer. When I double click on the transformer, you can see on the right hand side again primary turns, secondary turns comes into picture. What is this all about? It is the number of turns you can see over here, which is there for the primary, and the number of turns for the secondary. You can change that. Now presently it is 10:1. You can change that for, let it be 1:3. When it is 1:3, what does that mean is primary, if there is only 1 turn, then the secondary will be 3 turns. Similarly, if primary is 2 turns, secondary will be 3 into 2, that is 6 turns. So that is the ratio. So that is what it is called, 1:3. So it will be a multiplication of 3 in the secondary compared to the primary coil. Now again, this is a resistor. You can also change this resistor value by double click on the resistor, and you can see over here, you can change that to 10k. Any value you can change it. Let it be 10k for that. You can also do it by clicking over here. You will be able to change it to any value much easily by dragging this terminal over here. So that is also comparatively easy. Okay, so there you are. So we have already identified the transformer ratio, we have identified the supply voltage and frequency, and also we have identified the resistor value. Now before running, there is one more thing which we have got put in. So that is, if we run it at this point, we won't be able to see the voltage and current flowing through the circuit. For that, we need probes. So where do I find probes? Here is the probes. You will be able to connect voltage probe and current probe. Click on this, left click, and you will be able to see that voltage probe, this is voltage probe and this is current probe. Voltage and current together it can be shown. So let us take only voltage and current separately. Voltage, let me left click that, one left click. I will be first checking the voltage here at the primary, that is my first terminal. Again I will take the voltage again, which for which I will be using it for checking the secondary voltage. There you are. Now again I will click on to get current of the primary. I'll be connecting it at this point, that is the primary current, and once more current again, take it and connect it to the secondary terminal. So what is this for? This probe is meant for showing or displaying the voltage and current, the voltage present at a particular point and the current passing through a particular line. So V stands for voltage at that particular point, and A here stands for the current flowing through that particular circuit. So similarly, I have put one voltage probe and current probe here to identify the secondary voltage and current flowing through the secondary circuit. Right, now let me run this circuit. So for running, you have got to come over here. You can see that run simulator. So I can run it over here by clicking on this run button. You can see that now the voltage and current in the both primary and secondary, it is continuously changing. You can pause it at any time you want. You can see that at this point it is minus 190, 1.9 volt, and all these are negative. Let us stop it at a place where it is positive. Yes, there you are. So you can see that this is a positive voltage, 206.58 volt is the primary, while in the secondary it is 619.73 voltage. How is that possible? What is the the relation between the primary voltage and the secondary voltage. The relation is the turns ratio which we have provided. So here you can see that it is very clear at the primary it is 206 or 206.58 voltage, while in the secondary it is 619 or 619.73 volt. So it is clear that there is a multiplication factor happening, and that multiplication factor is 3. So 206.58 into 3 gives the voltage which is shown on the right hand side. Again, when you see the current 185.92 milliamp is the primary current, while the secondary current is 61.973 milliamp. So what is the relation? Is there a relation? Yes, there is a relation. The secondary current is 1/3 of the primary current. So that is the relation. You can see that it is just the reverse. Current is just the reverse of the voltage. When the voltage is multiplied by 3, current is divided by 3. How is that possible? So that is possible because by default in a transformer, when you take the primary power will be always equal to the secondary power. So to maintain the power is nothing but voltage multiplied by current. If the voltage at the secondary increases compared to the primary, and the only way to keep the power same compared to the primary is reduce the current to same level as the increased voltage. So if voltage is increased by factor of 3, the current must be reduced by factor of 1/3, so that the power remains same. Right, now let us see the waveform of this. So for seeing the waveform, we have got to click either this graphics, or we will put it in a split mode, wherein which both the circuit and the graph will be shown. So we have got to make some few modifications in the graph to get the clarity on the graph. You can see over here PR1, PR2, PR3, PR4. What are those things? PR1 is the voltage at the primary, PR2 is the voltage at the secondary, PR3 is the current at the primary, and PR4 is the current at the secondary. Let us first start with PR1 and PR2. Right, so let me make small modifications so that the waveforms are clearly visible. So because it is at a 50 Hz frequency, normally I need to make the time limit which is in x-axis in milliseconds. So you can see that when I have changed into milliseconds, I have started seeing voltage waveforms. Now the voltage level here, I will make it from -800 to +800. Yes, so you can see that all the waveforms has come well within the limit. And again, coming to the current, I will make it as -1.5 to +1.5. Now you click on this, you can see that the current also is shown over there. So where is that current in this waveform shown? Here is that current is shown in this is also y-axis. Current is shown at this right side of the waveform. Voltage is shown at the left side of the waveform, while time is shown over here. So time starts from 0 to 50 millisecond, while voltage changes from -750 volts to +750 volt, and current changes from -1.5 to +1.5 voltage. So you can see that this is a trial and error to identify, and of course because you have given already 240 volt, normally when it is multiplied by 3 it is 600 to 700 between. So you know what would be the voltage level which you have got to set to get that voltage waveforms and current waveforms correct. Let me just remove the PR3 and the PR4. So that is it. The green one, you can see here, V green is this green one, input voltage or the primary voltage, while the blue is the secondary voltage. It is very clear that the voltage has gone up. So what does that mean? It is called a step up transformer. This transformer acts as a step up. The voltage is going high compared to primary. The secondary voltage has tripled. So the primary voltage, it is near to 250, secondary voltage is near to 750 voltage. So it is very clear that this transformer is a step up transformer. And how it is a step up transformer? Here we have already identified initially as a turns ratio. We have given it as 1:3. So that itself tells that this transformer must act as a step up transformer. If we have given 3:1 turns ratio, then it would become a step down transformer. If the input voltage was 250 voltage, it would be 1/3. The output voltage will be 1/3 of the input voltage. To see this current waveform, waveform, I have already removed the voltage waveform from the circuit. To see the current waveform better, you can still modify it, because you can see that the current waveform is a little smaller. We can adjust the range here. So let this be minus 500 milliamps to plus 500 milliamps. So I have now adjusted. You see that the upper limit and the lower limits I have adjusted. That's why you can see that the waveform it is much more clearer. And this is the current which is at the primary and secondary. Primary current is a bigger one, the bluer one. You can see that the probe color which you have put connected to the primary is what is being shown here. The blue one is the current which is flowing through the primary, and the pink one is the secondary current. So you can see that it is very clearly visible that voltage has been multiplied by 3, or in case of voltage there is a step up, while in case of current it is just the reverse. That is, the current has reduced by 1/3 while voltage has increased by 1/3. Now let us see on what will happen when I change the load resistance over here. You can see over here now that presently now it is 10 kilo ohm, and this is a current which flows. You can see that it reaches 200 milliamps at a peak. So let us see what would be the effect of the change in resistors. If I increase the resistor value, what would be the effect of a current flowing into the secondary and in turn primary? So for that we have got to double click on this, and you can see over here the terminal comes into picture. You can just move this slider to change that to 20 kilo ohm. You can see that now it has become 20 kilo ohm, and now I need to restart it again. So once I start it again, you can see that I click on here the run button, and it is started simulating. I will pause the signal and click on this waveform, and once I click on the waveform, let me select only the current presently, and I will modify the time as 0 to 50 milli as before. Yes, and now you can see that compared to the previous wave was 200 milli was the maximum current, 200 milliamps. Now you can see that the maximum current has halved, like it has become now 100 milliamps. So with the increase in resistance, the current flowing also comes down. So here the resistance value has been doubled from 10 kilo ohm to 20 kilo ohm. So what happened to the current? Current has been halved. So more the resistor, while increasing the resistance value, it is actually ensuring that the current value flowing through this circuit is coming down. More the value of resistor, lesser will be the current flowing. So here the double the resistor has been made. So what about the current? The current has been halved. So that is the effect of a load resistor on the circuit. That's the end of this transformer and its turns ratio. Hope all of you have enjoyed watching this video. Let's meet again in my next video. All the best for your online learning session. Thank you.